Hi, welcome to Apache Hadoop 3x course. I'm Abhishek Sakuja from UpDegree, and in this video we are going to take a look at introduction to Hadoop 2x. In a previous video we have already understood that how exactly 1x look, and in this video we are going to take a look at high level architecture of Hadoop 2x. What are the components involved? So we are going to see that what are the different similarities, like we have already talked in 1x and now in 2x, what are the different components that has been added, and how Hadoop 2x works, and finally an improvement over Hadoop 1x. So this is the same high level architecture which you have already taken a look in 1x, but if you observe the highlighted difference over there, so that is what we have the yarn, because we have already talked about what is Hadoop common module. It's an API which helps you connect to Hadoop. Then HDFS, which is your Hadoop distributed file system, like your storage layer of Hadoop. We have talked about MapReduce, that MapReduce is a computation layer, Hadoop ecosystem, that there are many ecosystems that has been built on top of Hadoop. But what exactly this yarn in? Why this has been built on top of Hadoop 2x, why it was not available in 1x, why we have in 2x. So yarn is yet another resource negotiator. In 1x, the computation layer where we have the job tracker and the task trackers, the job tracker, which is a master in Hadoop 1x for computation layer, is overloaded. So in that way, this new component has been built up to offload some of the work, which of course we are going to see the difference when we are going to talk about the architecture of yarn, right? And in this you'll come to know that how the things has been offloaded. So this is a cluster management component in Hadoop which takes care of your computation layer. So now whenever you want to run any kind of computation on top of Hadoop, your application is going to get in contact with yet another resource negotiator. So this is the most differentiating factor. Of course there are much more differentiating factor, but the most important one is this, and there is another called as high availability, which we are going to soon talk about. So this is the 2x component. So as in the previous Hadoop 1x components, we have already taken a look that we have NameNode, we have secondary NameNode, we have task trackers and the DataNode. But here, if you look, we have some more components that has been introduced in 2x, and this is to make your Hadoop environment more reliable, more scalable, and so that your more application can run on your Hadoop environment, and with better resource management. So if you take a look on the left hand side, so here we have kept a secondary name node, but I'll tell you that this is not needed with 2x. This is just to show you that yes, if you want, you can still have secondary name node, but now none of the organization uses the secondary name node in their production environment for 2x. It's always we have a high availability of name node. So if you see that we have two name nodes, one is called the active name node, another one is called the standby name node. So this is exactly called a high availability in your Hadoop 2x. This makes not getting a single point of failure of name node. So we are going to talk about like how exactly this active name node and standby name node works together, because this is very important concept to understand and think about, like when you're going into the production environment, if your master fails, everything is failed. But with the introduction of high availability, even if one of your master, like your active name node, fails, you still have the another one available to become a standby at the same point of time, which means these two, active and the standby name node, they are in sync with each other. So one fails, the another comes up, and by the time you can fix another one, so you have the high availability environment available for you, right? So it becomes simple. Now how this active and standby becomes highly available, of course you cannot say that you just go and sync there, but there should be some components which are helping it to make this environment is sync and they're high available. So for that we actually use general nodes, which I'm again going to tell you in the architecture of NameNode high availability, and which are also called as share edit log. So this is the place where you store your common log files, and that's why the active name node and standby name nodes become sync with their what are the changes that have been made on the cluster. Along with that, when you're going to talk about this high availability, we are going to see two new components. One is like a Zookeeper, and the one is Zookeeper failover controller. So that will be coming in the next video. So DataNode remains the same. So it is the same DataNode that we have seen in 1x, but if you observe the difference, there is a node manager, there is a container, there is an app master. So this is the thing which makes your application more reliable, running on the cluster of better resource management, because we have some more components. Task tracker has been replaced over here with a node manager, so which we have already taken a look in 1x. That's called task tracker, which is actually handling your task. Along with that, we have a containers and app masters, which we are going to talk about in when we are going to talk the yarn architecture, where we are going to see that how exactly resource manager, the actual replacement of your job tracker, is going to enhance your application experience. So on the right hand side, it's your yarn, which is your data processing layer. Now you don't have a job tracker, but you, instead of job trackers, you have a resource manager. Within resource manager, there is something called scheduler and app manager. Again, we are going to talk about this in when we are going to discuss the architecture of resource manager, like a yarn architecture. And these are the masters layer which you see on the top, which is secondary name node, active name node, standby name node, your resource manager. So resource manager, inside that there is a subtask, which is a schedulers and app manager. And similarly, the slaves, now we do not have task trackers, so therefore we have the data node and the node manager. All right, so this is what we have for the NameNode high availability. Now, how exactly it works? So NameNode high availability is the concept which has been introduced in 2x, because as we know that with 1x, the NameNode becomes a single point of failure because it's a master. If a master fails, you cannot do anything on the cluster is done. So therefore, they have come up with not one name node, they have come up with two name nodes. So on the left hand side, you can see that we have one active name node, and on the right hand side here we have the standby name node. So but how exactly they work in a sync manner? So this is a very famous image from Hortonworks website, which is one of the distributors of Hadoop, right? So they have very well depicted over here that how exactly this high availability works. So now, just before going that how this sync process works, like how the active fails and standby becomes your active, first of all, let's understand two more important components, which is one is general nodes, another one the zookeeper. So general nodes are your share edits, which we call as share edits, or some people also call as QJM, which is your general quorum manager. So it's a quorum of machines. We generally have 3 machines itself in the cluster. So therefore you can see there are 3 different general nodes, which are very light nodes, which can sit on any other master nodes as well. So what they do, whenever there is a write operation happens on a name node, the write are logged in to the general node, which is your share edits. So as soon as the data is being captured by the name node for all the metadata information, it is actually being written to these general nodes. Now these general nodes are in contact with your standby name node as well. So if there are changes happening in the general nodes, the name node, the standby name nodes keep reading those changes. So therefore, this active and the standby remain in sync with the metadata information. But how about the failure? What exactly the failure will, if active fails, how the standby can become active? So that is what we have Zookeeper for that. So Zookeeper is the one which is again a cluster, and here we call them as a Zookeeper ensemble. So this is always in odd digits like 3, 5 or 7, depending on how do you would like to, how big your production environment is. That is how you can select the number of nodes over there. So what exactly Zookeeper's servers are doing over here? So Zookeeper helps you maintain the state of the name node, whether active or the standby. So along with that, if you see on the right hand side, on the left and the right hand side, where we both have Zookeeper FC, that is a Zookeeper failover controller. These are the services which sits along with your name node. What they do, they are in contact with your name node and they keep checking. There is a lock that has been maintained in the Zookeeper with these name node machines that is managed by the Zookeeper failover controller. So the Zookeeper failover controller will try to take a look at the lock with a Zookeeper. So if Zookeeper is holding a lock with the name node, active name node, then that is the active name node. But the other Zookeeper will always try to monitor if the lock has been released. I would like to catch it, because if I don't catch it, I will remain in standby. As soon as I take the lock I will become active. So this is a very composed relationship between the zookeeper and the name node, so that they keep looking for the locks. As soon as, say about like if the name node fails on the left hand side, the lock has been released by the zookeeper, and the right hand side zookeeper for the controller will try to take a lock. As soon as it caches the locks, it makes a lock with the zookeeper. The right hand side standby name node becomes active. So this is how your name node high availability works. So this is what we have in this video, and in the next video we are going to continue, where we are going to take a look at how Resource Manager or the yarn architecture works and what is the difference between 1x and 2x. Thank you.